Intermediate Algebra for Statistics, Multiplication of Polynomial Expressions and Functions, Part 4. Lesson Objective: Use product functions to describe authentic situations. We'll begin with an example. Example 10. Use the data in Table 17 on the next slide. We can model the average salaries of professors at public colleges and universities. A reasonable model is S of t equal to 1.8 t plus 22.5, where S of t is the average salary in thousands of dollars at t years since 1980. The number N of t of such professors in thousands is modeled by the function N of t equals 0.8 t squared plus 3.5 t plus 685, where t is the number of years since 1980. So here we have the average salary in these years, and here we have the number of professors for these years. So A, check whether the models fit the data well. B, find an equation of the product function S times N. C, perform a unit analysis of the expression S of t times N of t. D, find S times N of 34. What does it mean in this situation? E, use a graphing calculator to determine whether the function S times N is increasing, decreasing, or neither for the values of t between 0 and 40. What does your result mean in this situation? Let's begin with A. So we have to hit our stats button. These are the number of years since 1980. And this was the average salary for professors. Next, we want to hit second and y equals, which is stat plot. Make sure it's on. Make sure you select scatter plot. Next, we want to hit zoom and number 9, zoom stat. Then we want to type in our model, which is 1.8x plus 22.5. Hit graph, and we see that this line is doing a very good job of modeling this data. Let's do N of t. So we begin by putting the data in list 1 and list 2. We turn our stat plot on. Again, hit zoom and number 9 for zoom stat. Hit y equals, type in our model, which is 0.8x squared plus 3.5x plus 685. Hit graph, and we see that this model is modeling this data very well. So to answer A, both models do a good job of modeling the data. B, to find the product function, we take S of t times N of t, use the derivative property for the 1.8t, and then use the derivative property for the 22.5. We should have 6 terms. We have 1.44 t cubed plus 6.3 t squared plus 1,233 t plus 18 t squared plus 86.75 t plus 15,412.5. Combining like terms, we have 1.44 t cubed plus 24.3 t squared plus 1,311.75 t plus 15,412.5. So this is our product function. C, for the expression S of t times N of t, we have S of t equal to the average salary in thousands of dollars per professor times the number of professors measured in the thousands. So the units of the expression are millions of dollars. D, to evaluate this function at 34, we substitute in 34, N for T. We cubed and square. Next we multiply here, here, and here. And then finally we add. And we end up with 144,700.56. And we're going to round this up to 144,701. So what does this mean in terms of the problem? In 2014, the total average salary for professors will be 144,701 million, or about 145 billion. Part E, to graph the function, we first want to put the product function in Y1. Next we want to hit window. I'm using -1 for my X-min. For my X-max, I'm using 41, and I'm counting by 5s. Next I want to hit zoom and zoom fit, which is 0. This feature will pick my Y values for my given X values. This is what the function looks like. And if I wanted to look at the table, I hit second and window, which is table set. I want it to start at 0 and I want it to count by 10. So we can see from 0 to 40, this function is increasing. So the function is increasing. This means that the total salary of professors have been increasing from 1980 to 2020. And this is the reason why I picked my X values from -1 to a positive 41 to allow for this. Thanks for watching.